Our second lesson is on inequalities. The process of solving a linear inequality is the same as solving a linear equation, except when you multiply or divide an inequality by a negative value, you must change the sign of the inequality. All right, so these are our signs we're going to be using for the inequalities. We have less than, greater than, greater than or equal to, and less than or equal to. All right, so we're going to solve the inequality, show every step, and then graph our solutions. So our first problem is n minus 19 is less than or equal to negative 38. Now this is very similar, like I said in the beginning, to solving the equations, except we have some inequality signs instead of the equal sign. So our inverse operations follow the same. Since negative 19, or 19 is subtracted from n, we are going to move 19 to the other side of the equation, or the inequality, by adding 19. This will get n by itself, and negative 38 plus 19 is negative 19. And we have the answer that n is less than or equal to negative 19. Now this means I can plug in negative 19 and this inequality will hold true. Or I can plug any other number less than negative 19 and this inequality will still hold true. This is my solution. When we graph these on a number line, I want you to put at least 3 numbers on your number line. So I'm going to use negative 19 as my middle number. And then I'm going to skip a space and put negative 20. And skip a space and put negative 18. Now, when we get to the actual graph of these, if it is less than or greater than, we're going to have an open circle since it's not actually equal to those numbers. But if I have greater than or equal to or less than or equal to, I'm going to put a closed circle because it's also equal to that value. So this one is equal to at negative 19, but it is also less than. So my arrow will be going to the left. And that's how we graph these. Number 2, our problem is negative x divided by 11 is greater than negative 7. All right, to get x by itself on this one, we have an 11 divided by here. But we also want to get rid of this negative sign at the same time. So if I'm divided by negative 11, I can multiply both sides by negative 11 to cancel that off. The negatives will cancel and the 11s will cancel. Now, I'm going to go back to the top here. Everything is the same except when you multiply or divide an inequality by a negative value. Well, in order to get x by itself here, I have to multiply by negative 11. So when I write this x by itself, I'm going to change the sign of the inequality. It is never going to be equal if it was not equal from the beginning. Right now it is greater than, so it becomes less than. Negative 7 times negative 11 gives me a positive 77. So if I plug in 77 into this inequality, it will not actually work because it's not equal to. However, I can plug in any other number less than 77 and this inequality will hold true. So this is my solution. Graphing this one, I'm going to put 76, 77, and 78. This time I cannot include 77. So I'm going to put an open circle on 77, and it is every other value less than it, so my arrow will go to the left. All right, let's move on to number 3. Your problem is 6x minus 8 is greater than or equal to 10. If you would like to try this problem out, pause the video, and solve the inequality. Okay, if you tried this problem out on your own, let's check your work. If you didn't get a chance to try it on your own, please write down these steps as we go. The first thing I noticed to get x by itself is that 8 was subtracted from it. So I first added 8 to both sides. Once I added 8 to both sides, I had 6x is greater than or equal to 18. Then 6 was multiplied to x. So that in order to get rid of the 6, I divided by 6 on both sides. Simplified, and I got that x was greater than or equal to 3. Graphing on my number line, I wanted at least 3 numbers on my number line, so I put 2, 3, and 4. Close circle on 3 because it was equal to at 3, but then it was greater than or equal to 3, so any other value greater than 3 as well. All right, let's move on to number 4. 120 is less than -4 times the quantity of -6 minus 4a. This problem is very similar to when we had our equations. The first thing that I'm going to do is distribute this -4 to both of these terms. So I have 120 is less than -4 times -6, which is a positive 24, and -4 times -4a gives me a positive 16a. Getting a by itself, I have 16 multiplied and 24 added. It's a positive 24, so I'm going to subtract 24 on both sides. This will give us 96 is less than 16a. Then 16 is multiplied to a, so I'm going to divide by 16 on both sides. And I get that 6 is less than a. Now before we graph this and before I box this in, we need to put this in the standard form. I need to put the variable first, just like we would write the variable first if this was an equation. The only difference is if I read this backwards, 6 is less than a, but a is greater than 6. So if I'm going to rearrange this, writing a first, I'm going to flip that sign to greater than 6. So now I still have the same exact value and I've not changed the problem. So if I plug in 6, it won't actually work in this problem because it's not equal to, but any other number that I choose to put in here, like 7, 8, 9, will hold true to this inequality. So make my number line 5, 6, and 7. 6 will have an open circle since it's not being included, but then any other value greater than 6 will be part of the solution. Okay, let's go on down to number 5. The problem is 6 times the quantity of 7 minus 7n is less than -168. If you'd like to pause the video and try this problem out, go ahead and pause the video. Okay, the first thing I did was distribute that 6 to the quantity of 7 minus 7n, which gave me 42 minus 42n, which was less than -168. Then I noticed here I had multiplication and I had a subtraction here, but 42 is positive, so I subtracted 42 on both sides and simplified. Then I divided by -42. Don't forget that negative sign does come down with it. And since I divided by a negative, this became n, flipping the sign to greater than, and this gave me a positive 5. So my solution is where n is greater than 5. All right, let's get to the next problem. Number 6, 5 plus 4p minus p is greater than 5 minus 4p. Now, two things I want you to notice here, similar to our equations, is we have variables in 3 different spots. The first thing we're going to do is we're going to get it in one spot on this side of the equation. So the first thing I'm going to do is I'm going to combine my like terms. So I have 5, and 4p minus p gives me a positive 3p is greater than 5 minus 4p. Similar to equations, I'm going to pick the smaller one. It doesn't matter if you pick a different one to bring it to a different side, as long as you stay consistent. So since negative 4 is smaller, that's the one I'm going to move to the other side of the inequality. Now that I'm moving to the other side of the equality, I do have to do my inverse operation. So I'm going to first add 4p to both sides. And I have 5 plus 7p is greater than 5. Now I have 2 steps left to get p by itself. The first thing I'm going to do with this positive 5 is subtract 5 on both sides. So now I have 7p is greater than 0. Since 5 canceled here and these 5s actually canceled here, I still need to leave a place value for that problem. Then to get p by itself, 7 is multiplied, so I'm going to divide both sides by 7. So now I have p is greater than, and 0 divided by 7 is 0. Any number greater than 0 will work in this inequality. So I'm going to put negative 1, 0, and positive 1. Open circle on 0, and it's going to the right. You can choose any numbers on your number line, but since I want 3 numbers, I typically choose 2 numbers on either side of the middle number, or the number itself. All right, so let's move on to number 7. The problem is negative 18 minus 2p is greater than or equal to 2 plus 2 times the quantity of 2 plus p. A lot of 2's in that problem. All right, hopefully you already noticed the first step in this problem. Since we have this quantity here, I am going to distribute this 2. You cannot combine these 2's here until you distribute this. So distributing that 2 first, I have negative 18 minus 2p is greater than or equal to 2, and I first have 2 times 2, which is 4, and 2 times p, which is 2p. Now, on this side of the equation, I have 2 constants that I'm going to combine before I move on. So I have negative 18 minus 2p greater than or equal to 6 plus 2p. Variables on both sides. Negative 2 is smaller than positive 2. So I'm going to start by moving this to the other side of the inequality. Since it is subtracting, I'm going to add it to both sides. Negative 18 greater than or equal to 6 plus 4p. Getting p by itself, I have to first move this 6. It's positive, so I'm going to subtract it to both sides. This gives me, move it up here, negative 24 greater than or equal to 4p. Next, I'm going to get this p by itself by dividing both sides by 4, since 4 is attached with multiplication. So now I have negative 6 greater than or equal to p. Before you get to graph this, don't forget to put it into standard form. So the first thing that I'm going to do is I'm going to change this and put p, and I'm going to change the sign. If I read this backwards, it reads as p is less than or equal to negative 6. So I'm going to change it to p is less than or equal to negative 6. And there's my solution. That will help make sure you get the arrow going in the correct direction. Graphing on my number line, I'm going to put negative 7, negative 6, and negative 5. Right? And then this will be a closed circle on negative 6, and my arrow will be going to the left. Okay, your next problem is, your last problem on the front page, -4 times the quantity of 6x minus 8 is greater than or equal to 2x minus 20. If you'd like to pause the video and try this problem on your own, go ahead and do so. All right, the first thing I did was distribute my -4 to that quantity, and I got -24x plus 32 is greater than or equal to 2x minus 20. Then I went ahead and moved my -24 to the other side of the equation. Since I have variables on both sides, I like to choose the smaller one. If you did not choose the smaller one, if you brought the 2 to the other side, then all you'd have to do is divide by a negative. So I went ahead and added 24x to both sides of the equation to have 32 greater than or equal to 26x minus 20. Next, I'm going to get this two-step equation, get x by itself, by adding 20 to both sides of the equation. Once I added 20 to both sides of the equation, I got 52 is greater than or equal to 26x. My last step to get x by itself is dividing by 26. Once I divided by 26, I got 2 greater than or equal to x. Hopefully, though, you caught this. You had to rearrange this to put into standard form, writing the variable first, which if you read it backwards, reads as x is less than or equal to 2. All right, let's flip it over to the back side and work out some word problems. All right, our word problems on the back side say, set up an algebraic inequality, solve your inequality, that's a small typo, and show every step. Our first one says 2/3 of a number plus 5 is greater than 12. Find the possible values of the number. Just like yesterday, I'm going to set my unknown to what the question is asking. So I'm going to use n for a number. Then I'm going to set up what it's told me. 2/3 of this number plus 5 is greater than 12. So 2/3 of a number plus 5 is greater than 12. And then we just have to solve our problem. So our two steps here would be first to subtract 5 from both sides. And I have this greater than 7. Now, remember with fractions, we don't divide fractions. Even though the fraction 2/3 is multiplied to n, we multiply this by the reciprocal. The reciprocal of 2/3 is 3/2. Notice here, once again, if you cross simplify, the 3's cancel and the 2's cancel. That's why we multiply by the 3/2. So then I have n is greater than, and this would just be 7/1. So 7 times 3 is 21. 1 times 2 is 2. And you can write that as an improper fraction. You could write it as a proper fraction, or you could write this one as a decimal. But I'm going to answer the question. It said find the possible values of the number. So I'm going to say the number is greater than 21/2. All right, number 2. This one kind of does a little more real world with it. Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of summer. He withdraws $25 each week for food, clothes, and movie tickets. How many weeks can he withdraw? So our unknown are the number of weeks. I'm going to set that to be W. And then I'm going to set up the problem. So he has started with $500 in his savings accounts. we know at the end he wants to have at least $200. We'll come back to that part. But from this 500, he is withdrawing $25 each week. So from that 500, we are going to subtract 25 each week. After he withdraws each week, he wants to have at least 200. So that means this must be greater than or equal to 200. Solving the problem, we have our two steps here. 500 is positive, so I'm going to subtract 500 from both sides. I'm left with negative 25W greater than or equal to negative 300. My next step is to divide both sides by negative 25 since it's multiplied. Now don't forget your rule. We divided by a negative value, so when we write this next part, we must flip this inequality sign. So it is no longer greater than or equal to, it is less than or equal to. And negative 300 divided by negative 25 gives me 12. So we are asked how many weeks can he withdraw? Well, it says right here the weeks must be less than or equal to 12. So he can withdraw 12 weeks or less. That will maintain his $200. All right, moving on to number 3. If you would like to try this problem on your own, pause the video and try the problem out. Okay, your school is having a fall carnival. Admission into the carnival is $3, and each game inside the carnival costs 75 cents. What is the maximum number of games that can be played for $10? So I've set G for my number of games. I know that it costs $3 to get into the carnival and 75 cents for each game. And I only have $10 to spend. So my inequality that I set up was 3 plus 0.75 per game, or G, less than or equal to $10. Solving this problem, I first subtracted 3 from both sides of my equation. Then I had 0.75 times G, which this is actually a fraction you could turn into 3/4 and use the reciprocal. Since it was in decimal form, I went ahead and just divided by 0.75. And I got that my games were less than or equal to 9.3 repeating, which I'm going to go ahead and just leave at this point for the answer. However, you cannot play part of a game. So when it said, what is the maximum number of games that can be played for $10? Well, I can't play 10 games because I wouldn't have enough with that $10. So I know I can play a maximum of 9 games. You could play 9 or 8 or 7, but this one just asked about the maximum number of games. Okay, the next one says, a school band will sell pizzas to raise money for their new uniforms. The supplier charges $100 plus $4 per pizza. The band members sell the pizzas for $7 each. What is the amount of pizzas the school band must sell to make a profit? All right, so our unknown is the number of pizzas that I'm going to set to be P. Now, when we talk about this school band selling the pizzas to raise money, they want to make a profit. It costs them money to buy the pizza, and then they're going to sell the pizza for a certain amount. So we want, in the end, their expenses less than their profits, or vice versa, their profit greater than their expenses. Their expenses cost $100 plus $4 per pizza. So 100 plus 4 per pizza. and I want this less than what they will make on them, $7 for each pizza. So I'm going to put 7p. All right, we're ready to solve. With variables on both sides, 4 is smaller than 7, so I'm going to start by subtracting 4p. Next, I'm going to get p by itself by dividing by 3. This is going to give me a fraction here, which I'm just going to go ahead and write as 33.3, and this one's also repeating, less than p. I am going to rewrite this, though, in standard form, just like we did before we graphed, and write p is greater than 33.3 repeating. Now, same with the number of games. We cannot sell part of a pizza. They're not selling them per slice, they're selling them per full pizzas. So in order to make a profit, they must sell, and it doesn't say the maximum or the minimum, it wants to know the total amount of pizzas. So they must sell, I must go all the way up. 33 will not make their profit more expensive than their expenses. So they must sell 34 pizzas or more, because this one is greater than, so we have to round up to 34 pizzas in order for them to make a profit. All right, number 5. Go ahead and try this problem out on your own if you like. If not, just play the video and I will work it out with you in just a moment. Pete is 120 pounds and is gaining 5 pounds each week. Randy is 145 pounds and is gaining 3 pounds each week. After how many weeks will Pete weigh more than Randy? So my unknown is the number of weeks that I've set to be W, and I want to know when Pete will weigh more than Randy. Or you can also have Randy less than Pete. Pete is 120 plus 5W for 5 weeks, greater than Pete or Randy, which is 145 plus 3W. With variables on both sides, I first subtracted my 3W, but you're also welcome to bring the 5 over. Next, I had a two-step equation, and I subtracted 120 from both sides. Then I divided both sides by 2, and I got that W was greater than 12.5. Now, you can interpret this one similar to the one we did with the pizzas and the games, and you can round up to 13 weeks, but there really wasn't a whole lot of information given. We don't know when they weighed in or if they were just keeping a tally throughout the week. So I left it as Pete will weigh more than Randy after 12.5 weeks. So you could put 13 weeks or 12.5 for this one. I would not be too picky on that, because time can be continuous. All right, our last problem says a 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns 0.5 inches per hour. The 18-inch candle burns 2 inches every hour. At what time will the 12-inch candle be taller than the 18-inch candle? So I need to know at what time. I'm going to set T to be my time. Or actually, in this problem, we're dealing with these candles every hour. But I'm going to want my 12-inch candle to be taller than or greater than my 18-inch candle. Well, my 12-inch candle starts at 12 inches. And it burns 0.5 inches every hour. So it is decreasing 0.5 each time. And I want this greater than my 18-inch candle, which is burning 2 inches every hour, or 2t. With variables on both sides, my 2 or negative 2 is smaller than negative 0.5, so I'm going to start by adding 2t to both sides. I have 12 plus 1.5t is greater than 18. Solving for t, I'm going to first subtract 12 since it's positive. And this is greater than 6. Divide both sides by 1.5. And I get that t is greater than 4. Now, once again, our time is in hours, so I know the 12-inch candle will be taller than the 18-inch candle after 4 hours. But it wanted to know at what time specifically, not just how many hours passing. Well, from the problem, we know they are both lit at 6 p.m. So 4 hours later puts us at 10 p.m. So I will say after 10 p.m., the 12-inch candle will be taller than the 18-inch candle. All right, check out the homework for inequalities. Please email me if you have any questions about the notes or the homework. Once you have finished your homework, please check your work on the homework answers.